Hi guys, in this video let's solve this problem together. Number 62, unique path. So a robot is located in the top left corner of an n by n grid, and we started from here. That's the robot, and the robot can only move either goes down or go to the right at any point in time. So the robot is trying to reach out to the bottom right corner of the grid, and we need to find how many unique path is possible there. So for example, in this one, we have 3 rows and 7 columns, and in this case we have a total 28 unique ways. So for example, one way would be the robot can go down and go down again, and then go straight to the right and go finish. That's one path. And second path would be the robot go right first and go down and go straight to the finish. Or the robot go to the right two steps and then go down and then go to the finish line again. Or could be the robot goes here and then go to the second row and then keep moving and then go down and then goes to the straight right. So I just list some example in here, but there are total 28 ways, unique ways to approach the starting point. And for this example here, we have 3 rows and 2 columns, and the number of ways is this many, 3 ways. And yeah, so I'm not going to walk through all the rest of the examples, and I'm going to implement it using a recursive function and also dynamic program. So first work through this recursive method. So as you can see, we first have the boundary condition where if the number of rows remaining is 1, or number of columns remaining is 1, so we automatically returns 1. So that basically means that if the robot goes to the last row, or if the robot is in the last column, and that is an edge case where it returns a 1. And whenever the robot moves 1 step here, so in this case the number of columns is decreased by 1, so it's going to be written in this case. Or if the robot goes down by 1 step, and that number of rows will get decreased by 1, and then we recursively call the function itself, and that is going to pass this test case, but it does not pass all of the test cases because it's too many recursions. It's too slow. And this can build up the intuition that we will can be utilized for our dynamic programming approach. So this is a dynamic programming approach. We first have a matrix that recording all the zeros. So let's look at this example here. Right. So we have in this example we have 3 rows and 7 columns. So we have 3 rows and 7 columns. If the robot were at this here, and that the number of ways will be 1 because the robot can go down here. Or if the robot is here and there's only 1 way as well, if the robot is at here, only 1 way. If the robot is in here, also 1 way. So this number is the same as this one, this number is the same as this one. However, in the corner, this gets a bit more interesting, where the robot can either go down, that's one approach, or the robot can go to right, that's another approach. So total ways will be 1 plus 1 equals to 2. And if the robot is here, and the robot can either go down, it has 2, in which case it has 2 approaches, or go to the right, in which case you have 1 approach, so it has 3. And if the robot is here, the robot can either go down, it has 1 approach, or it go to the right, it has 2 approaches. So in total, number of unique approaches will be 3. And in this case, the robot can either go down, in which case it has 3 ways, or go to the right, in which case it has 3 ways as well. So in total, it has 6 unique ways. So this dynamic programming approach, we can fill out this table from the bottom left, sorry, the bottom right, all the way to the top left, and this is where is the total number of ways, and this is exactly the answer. So, and it will initialize this matrix, and this we have DP, which stands for dynamic programming. It has a number of it's all 0 at the beginning. It's all n. So n is the sorry. So m is the number of So n is the number of columns, and then times the number of rows. And then at the end, what we need to do is just return dp at 0, 0, which is the top left corner. And now we have to figure out how to implement a function that determines the DP matrix using a dynamic programming approach. Okay, so this is the solution, and let me walk through the logic with you. So obviously the last row and the last column, we don't need to do anything about them because they will be the one. It's very trivial because we have only one way to go to the end, right? So we have only, if we are in the last row, we can only go to the right. We are in the last column, so we are only in the right. So the more interesting point will be in here. And so that's why I changed it from 0 to initialize the DP matrix to be 1. And then we using dynamic programming to go backward each time. So for example, so that's why m, as you can see, m minus 1. The first minus 1 because we are using an index, and minus 1 means we want to only look at the second last row from the bottom. And also the same for column, n minus 1 because we only talking about the index, and minus 1 again because we are only look at the second column from the last. So second last column instead of the last column, because last column again is a trivial case, we don't need it. And then we go backward, right, from here and go all the way to here. So the first, we look at the current number that is equal to the one is the sum of the two next steps. Either we go down in the row or we go to the left in the column. So we sum them and then recursively or dynamically go back to the initial starting point. And after we do that, it passes the test case, also pass all the test cases, and that's the result. And yeah, this is my solution. And two approaches. One is the recursive function, which is intuitive but maybe slow. It does not pass all the test cases in LeetCode. Another one is the dynamic programming. And this is my solution. I hope you like it. Thank you.